Let us solve it using the formulas. So I am trying to find the value of MCM 1, 4. I have to find the values where I can take this row as MCM of 1, 3 plus MCM of 4, 4 plus some cost of multiplication, MCM of 1, 2 or MCM of 3, 4 and some cost. Then I can say that I can also calculate MCM of 1, 1 plus MCM of 2, 4 plus some cost. And I will be taking the minimum of them. So now let me mark them as 1, equation 2 and equation 3. To further solve equation 1, we have to find the value of MCM 1, 3. So this will be equals to MCM 1, 2 plus MCM 3, 3 plus some cost, or I can say that it can be equals to MCM 1, 1 plus MCM 2, 3 plus some cost, and whatever values I would be getting, I would be able to get a minimum value, and that value I'm going to assign for 1, 3. Let us further break this problem. So for MCM 1, 2, I can further write it as MCM 1, 1 plus MCM 2, 2 plus some cost. Now we have already discussed that if I is equals to j, I'm going to straight away put the value as 0. Again, I'm also going to put the value of this as 0. Now this means that I am having a A matrix having a dimension of 2 cross 2, and then I'm having a B matrix having a dimension of 2 cross 2. So the total cost that I will be getting over here by multiplying these two matrices will be equals to 2 cross 2 cross 2, which will be equals to 8. So the value that I'm getting for 1, 2 is 8, and the matrix that I'm getting is AB 2 cross 2. Now I'm having a third matrix C, which is again having a value of 0, and since it has a dimension of 2 cross 3, I would be getting a matrix A, B, C of dimension 2 cross 3, and the total number of multiplication will be equals to 2 cross 2 cross 3. So this becomes equals to 12. So the total cost that I'm getting by solving this is equals to 12 plus 8, which is equals to 20. Let us solve it for this one. To solve this, MCM 2, 3 can be written as MCM of 2, 2 plus MCM of 3, 3 plus some cost. Now we already know since I is equals to j, I am putting value of 0. Since I is equals to j, I am again putting the value as 0. This is a B matrix with dimension 2 cross 2. This is a C matrix with dimension 2 cross 3. So the matrix I am getting from here is B, C with dimension 2 cross 3, and the multiplication I am getting is 2 cross 2 cross 3. It is equals to 12. So the value I am getting for this is 12. The value of MCM 1, 1 is 0. And if I multiply A having a dimension of 2 cross 2 with BC, I would be getting a multiplication value as 12. So the total cost I'm getting from here is 12 plus 12, which is 24. Now I have to find the minimum cost, so I can say that the minimum cost of MCM 1, 3 is 20. Let us consider two tables over here that we have to fill, which will be helpful at the end. So all the values that I'm getting over here will be, I'm going to put this in the multiplication column. So over here you can see that if the values of I and j are equal, so the value is equals to 0. So I'm going to put 0 over here, 0 over here, 0 and 0. The next value that we have got is for 2 and 3. The value is 12. So for 2, 3, I'm going to write a value of 12. Again, we got a value of 1, comma 2, which was 8. So I'm going to write 8 over here. Now let us solve our values for this second equation. So this becomes LCM 1, comma 2 plus LCM 1, 3, comma 4 plus some cost. So first let us find out LCM 1, comma 2. So LCM 1, comma 2 will be equals to LCM 1, comma 1 plus LCM 2, comma 2 plus some cost. Since the value of 1, comma 1 is 0 and 2, comma 2 is 0, we can say I'm having a A matrix having a dimension 2 cross 2, B matrix having a dimension of 2 cross 2. So the total number of multiplication will be equals to 2 cross 2 cross 2, which is equals to 8. Let us again find the value of LCM 3, comma 4. This will be equals to LCM 3, comma 3 plus LCM 4, comma 4 plus some cost of multiplication. So the matrix C is having a dimension of 2 cross 3 and the matrix D is having a dimension of 3 cross 1. So the total number of multiplications are equals to 2 into 3 into 1, which is equals to 6. So the value that I'm getting for 1, comma 2 LCM is 8 and LCM 3, comma 4 is 6. Now the matrix that I would be getting from multiplying A and B will be of dimension 2 cross 2, and by multiplying the matrix C and D together will be of 2 cross 1. Now here the value that I have derived is 8. The value of 3, comma 4 is 6. Now the total cost of multiplication will depend upon the matrix. Since AB is of dimension 2 cross 2 and CD is of dimension 2 cross 1, I can say that the total number of multiplication that is required is 2 cross 2 cross 1, which is equals to 4. So the value I'm getting by solving this equation is equals to 8. So I'm going to update this value in my above main equation. So the value I'm getting is 18 from here. Now let us fill our values in the table. So over here I can say that I have got a value of 1, comma 2 as 8, which I have already marked over here. So you could have directly picked it from here instead of solving it. And for 3, comma 4 I'm getting a value as 6. So I'm going to write it over here. Next equation is LCM 1, comma 1 plus LCM 2, comma 4 plus some cost. So we are going to first calculate LCM 2, comma 4. So this will be equals to LCM 2, comma 2 plus LCM of 3, comma 4 plus some cost, or it can be LCM 2, comma 3 plus LCM 4, comma 4 plus some cost. And we are going to supply the minimum value to 2, comma 4. Now we know that the value of 2, comma 2 is already 0. We have to find the value of LCM 3, comma 4. This can be written as LCM 3, comma 3 plus LCM 4, comma 4 plus some cost. Now since the value of 3, comma 3 is 0 and 4, comma 4 is 0, the matrix C has a dimension of 2 cross 3 and the matrix D has a dimension of 3 cross 1. Multiply CD is equals to 6. Now let us check the total cost that I'm getting over here. So I can say that the total cost I got was 6. So the matrix B over here was having a dimension of 2 cross 2 and the matrix CD over here was having a dimension of 2 cross 1. So the total number of multiplication that we got was 2 cross 2 cross 1, which is equals to 4. So the total cost that I'm getting from this equation is equals to 10. Let us find the cost we are getting from this equation. So for this, we are going to find the value of LCM 2, comma 3, which will be equals to LCM 2, comma 2 plus LCM 3, comma 3 plus some cost. So the cost of 2, comma 2 is 0, 3, comma 2, 3 is 0. Matrix B is of dimension 2 cross 2. Matrix C is of dimension 2 cross 3. So the total multiplication will be 3 to the 6 to the 12. So this will be equals to 12. The value I'm getting over here is 12. The value I'm getting over here is 0. The matrix I'm getting over here is B, C, having a dimension of 2 cross 3, and the matrix I'm getting over here is D, having a dimension of 3 cross 1. So the total number of multiplication that I got is 2 into 3 into 1, which is equals to 6. So the answer I'm getting for this equation is equals to 18. So the minimum of both the values is 10. So the value of 2 comma 4 is will be equals to 10. Let us fill our values into the table above. So over here you can see that I have found the value of 2 comma 3 as 12. See, I already have this value, so I could have straight away used it instead of again calculating it. And then the value of 3 comma 4 is 6. Again, I'm already having this, so it was not required to solve it. You could have directly picked the values from here. The value of 2 comma 4 that I'm getting is 10. 1 comma 3 is 20 that I was getting. So now I have to find the value of 1 comma 4. You can see the value of 1 comma 3 was 20 and the value of LCM 4 comma 4 is 0. The matrix ABC was having a dimension of 2 comma 2 cross 3 and the matrix D was having a dimension 3 cross 1. So the total number of multiplication we got was equals to 6 and the total cost was 26. So the total cost of 2 comma 4 that we were getting was 10 and the matrix we were getting was BCD having a dimension of 2 cross 1. Similarly, this value is equals to 0 and the matrix over here is A having a dimension 2 cross 2. So the total multiplication that we are getting is 2 cross 2 cross 1 which is equals to 4. So the total cost is equals to 14. The minimum cost from 26, 18 and 14 is 14. So we will be having a cost of 14. What is update the value over here as 14. So minimum cost to multiply ABC is 14. Now we have to check in which order we have performed this multiplication. For this, we are going to use this parenthesis matrix, where for the diagonal, we are going to put 0 as we have done for the multiplication matrix. And now we have to find the values of upper triangular matrix. So to find the value of 1 comma 2, you can see that this 1 comma 2 was obtained from 1 comma 1 and 2 comma 2. So we will be taking this value as 1 and we'll be writing it as 1 over here. Now to find the value of 1 comma 3, we got the value from this equation as 20 was minimum over here. And the matrix that was we are having was 1 comma 2 and 3 comma 3. So we are going to pick this value as 2 and we'll write it over here. Now we have to find the value of 1 comma 4. So you can see that the minimum value that we were getting was from this equation and the matrix that we were having was 1 comma 1 and 2 comma 4. So we are going to pick this value 1 and we'll write it as 1 over here. To find the value of 2 comma 3, we have got this value from 2 comma 2 and 3 comma 3. So we are going to pick up this value and we'll write 2 over here. Then we have to find the value of 2 comma 4. So for this 2 comma 4, we have got the value from this equation and the matrix for 2 comma 2 and 3 comma 4. So we are going to put the value of 2 in our table over here. Next, we have to find the value of 3 comma 4. So for 3 comma 4, we were using the matrix 3 comma 3 and 4 comma 4. We are going to pick this value 3 and we'll put it over here. So now let us understand how the parenthesis has been fixed. So A, B, C, D, where A is 1, B is 2, 3 is C, and D is 4. Then we can see that at the fourth index, we are splitting our matrix at the first position. So basically, you would be getting A, B, C, D as the next step. Now, from the B, C, D, we can see that we have split our matrix from the second location. So I can say that this becomes A, B. We have split it from the second position, so this becomes C. So basically, we are first multiplying CD, then we are multiplying B, CD, and then we are multiplying A, B, C. This is the order from where we have got the minimum cost for multiplying these four matrices.